Hi, I'm Livia Gerber. I work on the segmentation of anatomical models at ITIS Foundation. In this video, I will guide you through the segmentation of a part of a human leg, the shank, using iSeg, a program developed in-house that has also been made commercially available. The segmentation in this movie is based on magnetic resonance images, also known as MR images. However, iSeg also recognizes other formats of medical imaging data, for example from X-ray computed tomography or CT scans. Prior to the segmentation of a tissue, we consider our internal guidelines, containing information about how every anatomical structure has to be segmented. We have also defined the structures, for example, certain blood vessels that are mandatory. These guidelines ensure that the differences between our models reflect actual anatomical differences between the scanned volunteers. As a first step, we separate the body from the background by defining the outer surface. This is done with the help of the threshold tool. Thresholding techniques are well suited to separate tissues with a clearly distinguished gray level range, as found between the body and the background, for example. All anatomical structures are in a first step assigned to the tissue fat. All tissues, like bones, blood vessels, muscles, will then be segmented over the fat. We now use a function called close holes to fill gaps of a specified size inside the region defined as body. To check whether we identified the correct boundary between body and background, it is convenient to switch between planes in various orientations. This function is handy as some tissues, for example the vertebra, can be segmented much better when the plane is changed. The close function in the Morpho tab can be used to close small gaps, bays, and holes to generate a smooth surface. Similarly, small islands and thin links can be deleted with the open function. Both of these functions rely on expanding or shrinking a region before resizing to the original size. Now that we have successfully separated body and background, we can start with the segmentation of the two bones in the shank, tibia and fibula. The tibia can be seen on the upper right side and the fibula to its left. In a first step, we segment the tibia. The tibia is segmented with the help of two tools, the brush and the interpolation tool. In a first step, we select the brush tool, which is found in the OLC tab together with various other outline correction tools. We then outline the tibia on every 10th slice with the brush size set to 4 pixels. It is sufficient to paint the tibia on every 10th slice, as the tibia is a rather large bone with a quite consistent course. You can see that in iSeg, the window to the left shows the MR image, which serves as basis for the segmentation, whereas the right window displays the segmented tissues. Now we come to the second tool involved in the segmentation of the tibia, the interpolation tool. The slices where we have outlined the tibia are employed as start and end points for the interpolation. Interpolation not only saves a lot of time, but also results in a smoother surface of the structure. After interpolating, we can see a continuous structure. The tibia is nearly segmented. To finish the segmentation of the tibia, we segment the 3 bone layers, consisting of cortical and cancellous bone and bone marrow. These layers have a constant thickness and can thus be segmented automatically with the Add Skin tool. In a first step, the thickness of the layer needs to be determined. This is where the measuring tool proves to be helpful. Simply measure the dimensions of the layer to be segmented as it appears in the MR images, either in millimeters or pixels. Then select Add Skin in the OLC tab, enter the desired thickness, and specify whether to add an outer or inner layer to the structure. The bone marrow is segmented similarly. except that it is added as an inside skin layer. Just like this, we have segmented the 3 layers of the bone: cortical bone, cancellous bone, and bone marrow. The tibia is now segmented. The fibula is segmented in the same way as the tibia. The structure is identified, outlined on every 10th slice, interpolated between the slices, and the different skin layers are added with the Add Skin tool. The next step is to segment the blood vessels. Here we start by outlining the vessel on every 6th slice. The distance between the slices is smaller compared to what was used for the bones, as blood vessels are thinner, change course more often, and occasionally branch. Once again, the interpolation tool is used. Thanks to topologically flexible interpolation, branching vessels are automatically recognized and segmented as such. All vessels are segmented in the same manner. First, we outline them on every 6th slice, then we interpolate. When interpolating, the Start button in the lower half of the interface indicates the starting point for the interpolation, whereas the Execute button defines the endpoint of the interpolation. The final step is to segment the muscles. The muscle tissue is segmented semi-automatically by thresholding. Here it is important to define an adequate threshold level. ISEG comes with a variety of semi-automatic and automatic thresholding techniques. For the muscle, we chose the threshold manually with the help of the slider. After the adequate thresholding level is found, click on the adder depicted by the plus on the right side, and assign the black parts inside the body to muscle. While scrolling through the slices, we can see that all important anatomical structures in the shank are segmented: the fat, the 2 bones tibia and fibula, the blood vessels, and the muscles. Interested in learning more about segmentation with ISEG? Visit us at www.itis.ethz.ch/VIP.